Hi, this is going to be lesson 4.4, solving multi-step equations with fractions and mixed numbers. So let's get started. Okay, solving multi-step problems with fractions and mixed numbers. And the objectives today is I can solve problems with rational numbers. Remember, rational numbers include fractions and decimals and all those numbers in between the whole numbers on the number line. And our standard is NS1. Interpret and compute quotients of fractions and solve word problems, that's today's part, involving division of fractions by fractions. Example, by using visual fraction models and equations to represent the problem. So I'm going to minimize myself. So we got the full screen available to us. So here we go. So solving word problems. When solving word problems, sometimes you will have to add, subtract, multiply, and or divide in any combination, all to solve one word problem. So these are multi-step problems, which means they're going to require 2 steps of calculations. Maybe adding and subtracting, maybe adding and multiplying, maybe dividing and adding. We'll see. Okay, here's the first problem. John is cooking enough lentils for lentil barley soup and lentil salad. The lentil barley soup recipe calls for 3/4 of a cup of dried lentils. The lentil salad recipe calls for 1.5 cups of dried lentils. John has 1/8 cup scoop. How many scoops of dried lentils will John need to have enough for the soup and the salad? Okay, when you get a problem with lots of words and lots of numbers, the first step is to underline the numbers and see what you've got. So let's underline the numbers in the problem, and then let's look at the question. The question is always the last sentence of the word problem. So we need to know what question we have to answer in the end. So we have 3/4 of a cup. That's the lentils. We know the salad requires 1.5 cups. So the soup requires 3/4 of a cup. The salad requires 1.5 cups. And we know that we have a scooper that will only scoop up 1/8 of a cup every time. So how many scoops are we going to need to make the soup and the salad? Okay, so that's what we've highlighted. Step 2, figure out if you will add, subtract, multiply, and or divide. Well, what do you think? If we need to figure out the total amount of lentils we need, what is that going to mean? Right, the first step is going to be adding, right? We have to add the amount of lentils for the soup and the amount of lentils for the salad. After we add that up, then what are we going to do? Well, let's figure it out after that. So let's go on to the next step. So we will add to find the total lentils needed for both recipes. And then we're going to divide the answer to find out how many scoops of lentils that John is going to need. So we're going to add, and then we're going to divide. So let's go to the next page here. Same problem. So let's add first. So we have 3/4 plus 1.5. Notice how the bottom numbers are not the same. So we have to get them the same before we can add. With adding and subtracting, you have to have the same denominator. So I'm going to keep it to 4s. So that 3/4 will just stay 3/4. How about 1/2? I'm going to multiply by 2 on the top and the bottom, and I'm going to get 2/4. Now I can add them. So 3/4 plus 2/4. Remember, we only add the top numbers, the 3 and the 2. That will give us 5, and the bottom number stays 4, 5/4. That's an improper fraction. We can't keep it like that. So we have to convert that to 1 1/4. How did I convert that to 1 1/4? If you forgot how, you can go back and watch the videos from adding fractions. But I put the 5 on the inside and the 4 on the outside. 4 goes into 5 one time. 4 times 1 is 4. 5 minus 4 is 1. That 1 comes up and becomes my numerator, and my bottom number stays a 4. So that's where I got the 1 1/4. However, I have this 1 over here yet that I have to add. So we got to add that in yet. So 1 plus nothing else over here is 1 whole number. But now I've got to combine the 1 plus the other 1. That's a whole number, right? So 1 plus 1 is 2, right? And then the 1/4 comes along. So the answer, the final answer for the first part of the word problem is he needs 2 1/4 cups of lentils. Okay? That's how many total lentils he needs. Now step 4 is going to be, we have to divide the total number of lentils divided by the size of his scoop. His scoop is 1/8 of a size. So 2 1/4 divided by 1/8. So before we can do anything, we have to change our mixed number to an improper fraction. So whole number times the bottom plus the top, clap, clap. Whole number times the bottom plus the top, clap, clap. So 2 times 4 plus 1 should be 9, and then the 4 stays on the bottom. So we've just converted 2 1/4 to 9/4 divided by 1/8. Now we use keep, change, flip. 9/4, we keep the first fraction. We change the division sign to multiplication. If you've forgotten how to do this, go back and watch the fraction video on dividing. And then we flip to the reciprocal of the last fraction. 8 becomes the top number, 1 becomes the bottom number. And that gives us, well, let's cancel our 4 and our 8. 4 goes into 8 twice. 4 goes into itself once. So always cancel when you can. So now we multiply across the top, 9 times 2, and across the bottom, 1 times 1. That gives us 18 over 1. Well, any number over 1 is just the number 18, right? So he will need 18 scoops. John will need 18 scoops of dried lentils for his recipe. Let's go double check our question up above. How many scoops of dried lentils will John need to have enough for the soup and the salad? Did we answer our question? Yes, we did. He will need 18 scoops. Okay, let's try another one. Before conducting some experiments, a scientist mixes 1/2 gram of substance A and 3/4 gram of substance B. If the scientist uses 1/8 gram of the mixture for each experiment, how many experiments can be conducted? Step 1, underline all the numbers in the problem and the question. 1/2 gram, 3/4 gram. He uses 1/8 gram of the total mixture. And how many experiments can be conducted? Then we have to figure out, are we going to add, subtract, multiply, and or divide? Well, if you mix two things together, that suggests to me that you want to get a total. So we're going to add to combine the two substances, right? And then what are we going to do? He uses 1/8 gram of the mixture for each experiment. So that to me, when you hear the word each, sounds like a dividing problem. So the second step is then we're going to divide to find out how many experiments can be conducted. This is very similar to the lentil problem. You have to add two numbers together and then you have to divide by the size of the mixture, or in our case before, the size of the scoop. So let's go ahead and do that on the next page. So let's add. So we're going to add 1/2 plus 3/4. Notice that we can't add them the way they are. The bottom numbers, the denominators are different. So we're going to change it to fourths. So this becomes 2/4. And if you've forgotten how to do that, go back and watch the adding fractions video. And then 3/4 will just stay 3/4. And then we add 2/4 plus 3/4, that gives us 5/4. And then that's improper, so we have to change that to a mixed number. That'll give us 1 1/4. You're going to divide the top number on the inside, the bottom number on the outside. And then if there was any whole numbers, we would add those next. I don't see any whole numbers over here on the left side. So that would be our answer then. There's nothing to add. So the total grams needed for step 1 is 1 1/4 grams. And that's a mixture of both substances, right? Now, how many experiments can he conduct if he needs 1/8 of a gram of that mixture for each experiment? That's the dividing part. So let's do that next. Okay, so we're going to divide. So our total was 1 1/4 when we added the 2 grams together. Now we're going to divide by 1/8 of a gram. So what do? We change the mixed number into an improper fraction. Whole number times the bottom plus the top, clap, clap. 1 times 4 plus the top, clap, clap. 1 times 4 plus 1 is 5. So 5/4 divided by 1/8. Now I use keep, change, flip. Again, if you've forgotten how to do that, go back and watch the video on dividing fractions. 5/4, keep the first fraction, change the sign to multiplication, flip the second fraction. 8 goes on top, 1 goes on the bottom. Cancel where you can and multiply across the top. 5 times 2 and 1 times 1. 5 times 2 is 10 over 1, which is just 10. So the scientist can conduct 10 experiments. Let's make sure we answered the question. How many experiments can be conducted? We did, right? The scientist can conduct 10 experiments. Okay, you get to try a word problem like this, and I'll see you back after you pause the video and do the question or questions. Okay, welcome back. Now we're going to focus on higher order thinking. Indira and Jean begin their hike at 10 a.m. one morning. They plan to hike for 2 2/5 of a mile marker to the 8 1/10 of a mile marker along the trail. They plan to hike at an average speed of 3 miles per hour. Will they reach the 8 1/10 mile marker by noon? That is the question. What do we do? Underline all the numbers in the problem and the question. The question is always the last sentence. So there's our numbers. We have 10 a.m. We have 2 2/5 miles. We have 8 1/10 miles. We have a speed of 3 miles per hour. And then the question, will they reach the 8 1/10 mile marker by noon? Okay, are we going to add, subtract, multiply, or divide? What do you think? Well, if they're starting here at 2 2/5 and they have to get to 8 1/10, we have to figure out how far. Let me just draw a little line here. So if we have 2 2/5, and they have to get to 8 1/10, we have to see how far away it is from here to there. How do we figure out how far away something is? We find the difference, right? So that tells me we're going to do a subtraction for one of the parts. So we will subtract to find the distance they need to hike. What are we going to do for the second part? We have a speed of 3 miles per hour. That to me sounds like dividing. We will then divide to find how long the hike will take. If they can go 3 miles in 1 hour, and we figure out how many miles they have to go with the subtracting part, we should be able to figure out how long it will take them. Next page, let's do the calculations. So let's subtract. So we're subtracting 8 1/10 minus 2 2/5. Notice how I put the bigger number 8 above the smaller number 2. Notice how my bottom numbers are not the same. If you've forgotten how to subtract with fractions, go back and watch the subtracting fractions video. Or you can look at the slides too, because I share those with you always. Okay, we're going to keep it as tenths. So the top is going to stay 1/10. The bottom, however, is going to be multiplied by 2 to give us 4/10. Now I can subtract. 1/10 minus 4/10. I have to borrow. I can't take a 4 from a 1. Again, If you need to go back and look at the video or the slides, please do so for the subtracting of fractions. So I'm going to borrow from the 8 and make it a 7. I'm going to bring 1 over. One whole number that I borrowed is coming over to the fraction side. I have to rename it. I can't call it 1. I have to call it some kind of a fraction. Well, since I have a 10 on the bottom here, I'm going to call it 10 tenths. Okay, but I already have 1/10 sitting there, so I have to add the two together. 1/10 plus 10 tenths. That should give me 11 tenths. And then I'm just going to bring this 4 tenths underneath. And now I can subtract. So 11, and you just subtract the top numbers. 11 minus 4 should be 7 tenths, right? And now I subtract the whole numbers. I got a 7 and a 2 to subtract, and that gives me 5. And then I'm going to combine the two. And I'm going to get 5 and 7 tenths. That's the first part of the problem. That's how far they have to hike. 5 and 7 tenths. Now we have to decide if they're going to make it there by noon. So let's go to the next thing. That's the miles hiked. So now we're going to do the dividing part. 5 and 7 tenths divided by, yes, 3. And I'm going to put the 3 over a 1 because I'm dealing with fractions. You can always put a 1 underneath a whole number. Now I have to change 5 and 7 tenths to an improper fraction. I get to sing again now. Whole number times the bottom plus the top, clap, clap. Whole number times the bottom plus the top, clap, clap. 5 times 10 plus 7, clap, clap. So 57 over 10 divided by 3 over 1. Now I do keep, change, flip. Keep the first fraction, change division to multiplication, and flip the second fraction. Cancel if I can. Do you see anything that can be canceled? You may not recognize it, but did you know that 57 and 3 divide into each other? You know how I knew that? You know how I knew that 3 would divide into 57? I added, this is a trick, I added 5 plus 7 out of the 57. From the 57, I had 5 plus 7. That gave me 12. And I know that 12 divides evenly by 3. So that means that 57 divides evenly by 3. So that's remember that multiple of 3 rule I taught you? That's a little shortcut. So I know that 57 will divide into 3. If I don't know how many times, what can I do? Well, I can do 57 divided by 3, and then it'll give me the answer, right? 3 goes into 5 once. 3 times 1 is 3. 5 minus 3 is 2. Bring down the 7. 3 goes into 27 9 times. 3 times 9 is 27. 27 minus 27 is 0. So 19. 3 times 19 gives me 57. So that's what I'm going to cancel here. I'm going to cancel the 57 into the 3. Now that black bar is at the bottom. There it goes. And 57 divided by 3 is 19. And 3 divided by itself is 1. And now I multiply across the top, 19 times 1, and across the bottom, 10 times 1. I get 19 over 10. Improper fraction. So how do I convert that? Well, if you forgot, you can always go back and watch the multiplying fractions video, but it's 19 divided by 10. 110 will go into 19. I subtract 19 minus 10. That gives me 9. So that 9 becomes my numerator, and my denominator stays a 10. So it should be 1 and 9 tenths. There it is, 1 and 9 tenths. And did we answer our question? It will take 1 and 9 tenths hours to hike. What is the question? Will they reach the 8 and 1/10 mile marker by noon? Well, 10 a.m. to noon is how many hours? 2 hours, right? 10 a.m. to noon is 2 hours. So it will take 1 and 9 tenths of an hour to hike, and this is less than 2 hours. So yes, they will reach their mile marker before noon. Okay, so you got to make sure you answer the actual question. 1 and 9 tenths is not the answer to the question. The answer to the question is yes, right? Yes, they will reach their destination before noon. Okay, there is no additional questions. You should be happy about that today. All you have to do now is to do your lesson, your homework from Google Classroom for lesson 4.4. So have a good day and we'll see you next time. Bye.